Okay, so after you guys have finished completing this chart, there are 3 different places that the variable showed up that you were solving for. So let's just look in the column with numbers 1 through 4, and on our note sheet, so you can rip this page off, that's totally fine. On our note sheet, we're going to put the 3 equations for which the variable we were trying to find. So the first equation that we had as a variable is we were just evaluating what is the base raised to the exponent. So we can use like number 1 to just say x became the answer. So let's write that in the notes of number 1. 7 raised to the, what was it, the 6th power or the 4th power? 4th power is equal to x. And what I'd like us to do is to think about what problems could we solve this without the chart with. So like, for example, in number 1, could you technically have solved this without the chart? Yeah, what could you have done? Yeah, just multiply it out. Multiply 7 times 7 times 7 times 7, and you get your answer. What was the answer? Just so I don't have to scroll back up. 2,000 what? 401? Thank you. Okay, so that's the first type of exponential equation you might have to solve. Just what is the answer? Go back, look at numbers 1 through 4. 2 is that same type of equation. You're just evaluating 9 to the 3rd. What's the answer? 3, you had the variable in a different place. You were looking for what's the value of the base. So when x is the base, this is just a different type of equation. So let's go write that in number 2. We had x to the 4th is equal to 1296. Could you have solved that one without the chart? Yeah, what could you have done? Yeah, take the 4th root. Take the 4th root of 1296. And then what was the answer? I know that you can do that on the calculator, but what was it in the chart? 6. You can do it with your calculator, but we want to see what do we currently have a method for solving for. So in 1 and 2, we can do that. Okay, and then lastly, what's the other type of equation? So that was the second type. The last type of equation is when x is the exponent. So let's go ahead and let's write equation number 4 as the last type of equation you were solving for. 2 raised to the x power is equal to, what was it? 5 what? 512? Okay, do we currently have a method for solving this type of an equation? Other than guess and check, right? Like you could try to guess it, but no, right now we have no method to solve. You could say other than guess and check. Other than just keep guessing what would work. Now, if the exponent is a whole number value, it might be easy to guess and check. Like what was the answer here for number 3? What was x equal to? 9. So you could have kept going, like what's 2 to the 8th, 2 to the 9th? But what if you have a problem like this? What if you have something where you have 3 raised to what power would equal 10? And you need an exact answer. It might be really, really hard to guess. What would you guess it would be? Yeah, you guys are using 2, excellent, because 3 squared is 9, and then you're adding to it. You're saying, well, it's 2 point something. So we know it's approximately 2 point, I don't know, something. We can find out in a moment. But obviously, we need a new method to solve exponential equations, specifically when x, the variable, the unknown, is the exponent. So which of these types of problems do you not currently have a method for solving algebraically? Number 3, when the variable slash, you might say the unknown, is the exponent. So when the variable or the unknown is the exponent. This is where a new mathematical idea comes in. It's called a logarithm. I'm going to define a logarithm for you, and then we'll practice using it on that one example. We'll see what is the exact value of, or 3 raised to what value would give us 10. So here's the definition of a logarithm. It says if a is a positive number and a does not equal 1, then if you have a raised to the x power equal to b, then you can rewrite this as log base a of b will isolate your exponent. Now I know that's weird. You have an exponential equation. You can rewrite it in a form to isolate the exponent. This is actually seen as an if and only if statement. In fact, I could erase the if and erase the then. Do you guys remember what an if and only if statement means from geometry?
Both sides are equal.
Yeah, it's reversible. So I could say if you have an exponent equation, you can write it in log form. And if you have a log equation, then you could write it in exponent form. Now the goal today is going to be to practice writing in this format so that eventually next week you can start solving with equations. So one thing I want you guys to be aware of, this is how I memorize it. The base of the exponent, so this I could go ahead and write it in as base, becomes the subscript of the log. In fact, when I have you read this back to me, I would ask you to read it as log base a of b, because that's technically how it's read and how it's understood in math. So this is the base of the log. It's the subscript. Subscript. Hope I spelled that right. Notice the x. The exponent is the answer to the log. So your exponent, and this is why we need this new mathematical idea, because we've never had a method to isolate the exponent before. So the exponent becomes the answer to the log. Your exponent is your answer to the log. Actually, just because this is the first time we're learning this idea, let's go ahead and write this in. The base of the log, well, we could keep it in that way, but you might want to say the base is the subscript of the log, but it's recognized as the base. And then lastly, the answer to your exponential equation now goes here, right next to the log. So this is where your answer comes. Okay, I know this is new, so this is going to be a lot of practice today. In fact, we might end with some whiteboards of just show me the equivalent log equation. So let's see if we can use this with that example that we were taking a look at up here. So let's take 3 to the x equals 10, and let's see if we can use this new mathematical idea. And then I'm going to have you take out your calculator and show you how your calculator could evaluate that exact number. So if I take this exponential equation and I rewrite it, so I could say, since I have this, then I know that I have this next piece. What would this look like in log form? 3 to the x equals 10 would be what? Log base 3 of what? 10 would give me my x value. Now, I don't have a calculator on my computer, so I'm going to jump to the different screen here, and I'm going to show you guys where you could do this on your calculator. So if I change sources here and I go to HDMI 2, I'm going to show you guys where you could do this on the calculator. Your log button, you might see it here. This is a special type of log. We need something that we could put the base in. And actually, give me a second. I think it's alpha y equal, no, function. There it is. There it is. Okay, so if you go to, second quit, there might be a quicker way. This is the one I know. If you go to alpha y equals, you're going to go over to function. So scroll over to function. And you're going to see something that you're going to use. Where do you think it's at? Log base, because we want to change the base. Now, what could we write in? in that base? What would I write in if I'm solving this example on the screen? 3 to the 10. So I'm looking at log base 3 of 10, and what's the answer? 2.095903. So you guys had some good guesses. Now here's how you can, I love checking my work in math. We can do 3 raised to that answer by pressing second negative. So if I press second and then negative, that brings back the answer from the previous line. What should be 3 raised to that answer equal to? 10. And so it just kind of checks my work for me. Charlie.
In our answer,
What decimal? They'll describe it. Usually I'll ask for the nearest 1,000, 3 decimal places. And then just so you guys know, sorry, I didn't tell you the quickest way. You should have pressed alpha window to get to that function. Sorry, I did it the wrong way. If we press alpha window, we can get to log base anything faster. So just so we know, I'm going to switch back to the screen here. And I'm going to write down those buttons that I pressed just for future so that you know that. But the x value, it was equal to 2.096. And just for future, to access that, you go to alpha, window, and it's option number 2, or wait, 5, thank you. Now we're going to be using the calculator more next week. I just wanted to show you guys why this is so valuable. But today's real practice is going to be just converting between the 2 forms. So let's go ahead and let's look at number 1. Without using your chart, let's see if we can figure these out. What would be log base, and without using your calculator, what would log base 4 of 16 be equivalent to? Well, you could convert it to exponent form to help you just figure that out. What would be the base of your exponent form? 4, so we would ask 4 raised to what power equals 16, and what would that answer be? 4 what equals 16? 2, 4 squared. So log base 4 of 16 is equivalent to 2. I'll do one more with you, and then I'll have you try the next ones with the group. So number 2, log base 6 of 1296 equals x. You're really asking 6 raised to what power equals 1296? You could use your chart if you wanted to. What power was it? 4? Is it 4 or 3? 4? Okay, with your group, go ahead and complete numbers 2 through 6. Thanks, Charlie. Does anybody know how to fix your pen if it starts like dragging?
Does it make that mustard?
Like, oh wait, I guess it stopped. It was like I didn't even touch the screen and it would like drag. Does that happen to you?
Sometimes you have to fix your tip on my case that again.
What?
It was free though. Cause like
What? I hope that's not. Oh well, I'll keep trying with this. Well, hopefully it'll fix. All right, for Jolly Rancher, for you and your group, can you tell me the answer to number 10 and to number 11? Nate.
10 is 6.
Okay.
And then 11, like the equation that we came up with was B, the exponent W equals M, so B would be 5.
Good.
W would be 9, and M would be
the big one, right?
Yeah,
195,
yeah,
3, 125. Yeah, I don't even know what that, but is equal to 9, right?
Yeah.
Nice. Give me a thumbs up on your desk, guys, if you got that. Answer to log base 2 of 2 to the negative third. Katie. -3, correct. If you were thinking about this without a calculator, which is what I hoped for you to do, but I didn't actually say that, so I apologize. But log base 2 of 2 to the -3rd is equivalent to 2 raised to what power is 2 to the -3rd? So you're looking at the fact that x has to be -3. So the answer is -3. So the rule that we would generalize this to is that log base x of x raised to any power, so let's not call it a, we used an a before, let's call it y, is equal to what? Just y. Excellent. And then this last one, I'll give you guys your Jolly Ranchers in a moment. This last one, how can we think through this one without the use of a calculator? Maggie, can you tell me how you thought of it?
I just figured out log base 2 times 4.
And what did that come out? So you said 2 raised to what power equals 4?
And after that,
X would have to be 2. Excellent.
so then b2 squared.
So you can look at 2 squared, which would have to equal 4. Yes. So the answer is equal to 4. And the relationship that you would be generalizing to a statement is that x raised to log base x of any number, so I'll call it y, would come out to equal y. Okay, these are the rules or the general statements that work with logs that can make your life simpler if you know how to use them or memorize them. Now, some of you were looking at your calculator and you might have seen that there were 2 logarithms in a different place than what I showed you. There's 2 and in fact, old calculators, so before the TI-84s, could only do these type. And we had to teach what's called the change of base formula in order to have students figure out any types of logs other than these 2. So they're highly used, and it's good to know what your calculator can do. So the 2 types of logarithms that you see are called a common logarithm and a natural logarithm. A common logarithm, it looks like this. It looks like a log button on your calculator. It's equivalent to a log base 10. So the log that you see on your calculator, specifically it's under the x squared button on your calculator, it's a log base 10. So for example, if you see a problem that looks like log of 100, you could rewrite that as log base 10 of 100, just because it's referencing a common logarithm. So without even using your calculator, what should the answer be to this? 10 raised to what power equals 100? 2. So the answer should be 2. But you could technically take your calculator, and I'll switch the source for a moment, just so you guys can see this. But you could technically take your calculator and just evaluate what is log of 100, because that's talking about a common logarithm. So I would do log 100, and I would find that the answer is equal to 2. Just so you guys are aware. And then the other type of logarithm, change it back. The other type of logarithm is called the natural logarithm, and you guys have actually already been working with this button a little bit with E. A natural log, it looks like this, is equivalent to log base E. So for example, if you see natural log of e to the 5th, that's equivalent to log base e of e to the 5th power. And based off of your work above, what should this answer be? Log base x of x to the y equals, yep, just 5. And you can see that by taking your calculator and plugging in natural log of e raised to the 5th power would give you just a 5. Okay, I'm going to do one of these with you at the bottom, and then I'm going to have you practice the rest with your group. Number 1, if you're evaluating log base 3 of 1 over 27, we want to try to use the rules that we generalized above. What could you change 1 over 27 into? 3 raised to what power? -3. Excellent. And if I do that, then I have log base 3 of 3 to the -3rd power. What should it come out to equal? -3. Excellent. Now I know I showed you guys your calculator, but there will be a non-calculator portion of the quiz next week. So try doing numbers 1 through 5 with your group without the use of a calculator. 5, and I'll give you guys Jolly Ranchers. Charlie, what'd you get for number 2?
4.
4, beautiful. Lydia, what's the answer for number 3? 37, awesome. Alex, what's the answer for number 4? I know this is kind of, it's written weird. You could rewrite this as e raised to the log base e of pi. So the answer would be pi, and I know that that number looks kind of funky. But yep, the answer is pi there. Number 5, you could rewrite this as log base e of e to the negative 1 power. So Garrett, what would the answer be for number 5?
-1.
Negative 1, very nice. All right, now I can give you guys Jolly Ranchers in just a moment. Okay, let's go ahead and just use your calculator and make sure you know how to compute these types of numbers. So number 1 is a common log. You don't have to change the base in any way. So I'll switch the source, go to HDMI 2, and if I type in log 2, most often they're going to ask you to round to the nearest thousandth. So just make sure you know how to evaluate that. That should be 0.301. And then number 2, if you're evaluating natural log, make sure you know that you can put in parentheses 1 plus root 2. And that should come out to be 0.881. If you need help on the calculator, I will